All right, the vast majority of what you're going to be doing is in these next two sample problems. Here's how you solve an absolute value inequality. All right, very first thing you do is you do the same thing we did with the standard absolute value. We solve for just this portion by dividing by 3 and 3 in this case. And then we get the absolute value of x minus 7 is greater than or equal to 9 divided by 3 or 3. Now I do something different. I set it up twice, but I have to flip the sign when I write the negative. So I'm going to say x minus 7 is less than or equal to negative 3. There's my flip and my negative, and then I write it as is. X minus 7 is greater than or equal to 3. Adding 3, I get x is less than or equal to 4, and x is greater than or equal to, well, what is that, 10. And we're going to get two lines going away from each other, and that's to be expected because we start off with a greater than. If you look at the notes on the last page, anytime you have greater than, you're going to get an or statement because I cannot be both less than 4 and greater than 10. So let's do the less than or equal to 4. That's a solid dot shaded below 4. The greater than or equal to 10 is a solid dot shaded above. And we're done with that one. Coming over here, same thing. We've already solved, right? And the absolute value is isolated, so it's set up. All I got to do is set it up in two different equations, and I'm going to do the negative first. So 2x plus 3 is greater than negative 5. Don't forget to flip the sign. Then we got 2x plus 3 is less than 5. I subtract 3, I get 2x is greater than negative 8. Divide by 2. X is greater than negative 4, which I'll, yeah, it's just greater than. Subtract 3, 2x is less than 2, divide by 2, x is less than 1. And notice, I can be both. I can be both greater than negative 4 and less than 1 at the same time. These don't have equals, so we do an open circle at negative 4, an open circle at 1, and this time I shade in between them, which is an AND statement, because I can do both at the same time. Now, that's what you need to be able to do. Look over those problems. Spend some time thinking about what I just did. Not a lot of time, but at least think about turning signs around. Talk to yourself when you do this stuff. Let's keep going with this. Let's do a real-world problem. Absolute values are often used to build real models. That's true, involving a margin of error and tolerance. Tolerance is a allowable amount of variation in a quantity. All right? So if a machine at a lumber mill cuts boards that are supposed to be 3.23 meters long, it is acceptable for that length to differ by 0.02 meters. Write and solve an absolute value inequality to find it. All right. The boards are supposed to be cut to 3.25, and I'm allowed for it to be 0.02 bigger and smaller. It's got to be pretty close though. So the actual length minus what we want, 3.25, has to be within 0.02, right? That can be greater than or less than. All right. So there's my equation. This is my real length, and if I subtract that, and as long as I'm not too bigger or too smaller, I'm okay. And too smaller is okay to represent with a positive because we put it in absolute value. So if I come over here and here's my equation. I set it up, turn my sign around for the negative, and then I leave it as is. So in this situation, if I add it, I go x can be greater than 3 so I add this to both sides, and that's going to give me 2, 3. Right? I do the same thing over here, and x can be less than, well now that's going to be a positive when I add it, 3.27. So my actual length is somewhere between 3.23 and 3.27. Both are within 3.23, 3.27. Both are within 0.02 of 3.25, right? Both are within that distance, all right? And that's it. I think there's one more, and we're going to see if we can do that one more. All right. Oh, look. It says justify it. Plug it in, which is always a good thing to check our answers. So the bounds are positive and close, right? As long as we're close to that 3.25. And since 3.23 plus 0.02 is 3.25, and 3.27 are two answers, minus 0.02 is 3.25, we're okay. All right, let's check the cereal box. All right, a cereal box is supposed to weigh 13.8 ounces, but it can vary as much as 0.01 ounces. So if we're going to write that, we're going to write this. The weight of my box is supposed to be, right, 13.8. All right, but we don't want it to differ from that by more than 0.1. There it is. My actual weight and this can't be different by more than 0.1. So let's set it up. We're going to go weight minus 13.8 is greater than or equal to negative 0.1. Flip the sign, and then weight minus 13.8 is less than or equal to 0.1. If I add 13.8 to both sides, I get my weight is, well, greater than or equal to, there's a negative 1, so it's 13.7. If I add it over here, I'm going to get weight is less than or equal to 13.9. And that's an inequality. We can just say, hey, you know what? My weight is greater than or equal to 13.7 and less than or equal to 13.9. And we can pretty much see, right, that they're each within 0.1 of the actual weight that we're shooting for. Let's go ahead and come down and solve a couple of these. We're going to do this guy right here because that's everything that you're supposed to do, right? How do you solve an inequality? Well, we isolate the absolute value, just like we did before. All right. We rewrite the equation. All right, as either an and or an or, really, right? And then remember to flip inequality when we add the negative. All right, and then we solve. All right. And we're going to stop there, okay? And I will see you guys soon.